IsoHorns, and today I want to talk about antenna patterns. IsoHorns was the first to bring high detail antenna patterns to the WISP industry, and I'm proud of that. And it was a difficult decision because prior to high detail antenna patterns, WISP were used to low detail antenna patterns. So over here is IsoHorns antenna patterns. And over here is our primary competitor's antenna patterns. And you can see the difference. This one is high detail. It is computer generated. It has lots of grid lines. This one over here is low detail, meaning it only goes to negative 30 dB, whereas this one goes to negative 48 dB. This appears hand-drawn, and you don't get the horizontal and the vertical polarities. It asserts that the vertical and the horizontal patterns are the same, and it only shows you one frequency, which is 5.6 gigahertz. With IsoHorns, we're giving you both the vertical and the horizontal polarities, and we give you three frequencies. We give you the low, the mid, and the high. Across the entire frequency range of our antenna. And this is important because it changes. And this is also important because the horizontal and the vertical, despite assertions by our competitor, are not the same. So this is important because if you have a subscriber that is off to the side, say at 30 degrees, operating at 7.2 gigahertz, you can see that the signal level is going to go down by about 10 dB here, whereas here it's going to only go down by about 5 dB. So there's going to be a 5 dB mismatch here, and this is shown. Here it's asserted that they're the same, but they're not, and we know that they're not, because this outperforms this every single time. So you're not getting the full story with this, and it shows because it appears hand-drawn and because it's low detail. Now on the negative 30 dB, what does that mean? Well, that means they're only showing you the antenna pattern from negative 30 dB to 0 dB. So from negative 30 to 0. You're only seen from here to here. So all of this information here is omitted. This is a little bit more obvious in the rectangular plot. So with these are the same antenna patterns. They're just represented differently. This is using a polar plot, and this is using a rectangular plot. And with this antenna pattern only showing above negative 30 dB, that's the same as only showing above this line. So all of the detail below this line is omitted. Well, why? Well, the only reason to omit this information is because they want to maintain the illusion that this antenna has no side lobes. But And we could have accomplished the same thing if we were imprecise and only showed negative 30 dB detail. And we could have also asserted that our horizontal and vertical polarities are the same. The other thing that is important, there's two important points to realize about antenna patterns. It's not like you get signal inside this line and you have no signal outside of this line. These are not beams. These are representations of signal levels. So if you're at 30 degrees, then operating on 6 gigahertz, then your signal is going to be 6 dB less than if you're at the bore site of the antenna. So if you're straight on, in the middle of the antenna pattern, you're going to get that signal, and then your signal is going to be 6 dB less if you're 30 degrees offset. That's what this represents. So it's not that there's no signal here and there's signal here. No, this is just the amount of signal at each angle. And the same is true down here. So here's 30 degrees, and that is -6 dB for 6 gigahertz. So that's how you're supposed to read these patterns. These don't represent beam shapes. That's one common misunderstanding. The other common misunderstanding is that this is a logarithmic scale. So -3 dB is half the signal. -6 dB is a quarter of the signal. So each one of these represents a huge change in the signal levels. But that's how RF works, is that it works on a logarithmic scale. So you can't just plot this on a map. It's stretched. It would have to be stretched to be accurately or better represented on a map. And again, it's not like there's no signal here and there's signal here. And this was especially, I would say, egregiously perpetuated. This false idea that this represents a beam was especially misrepresented with the 3D antenna patterns that our competitor did a few years ago. So they were helpful to kind of understand the 3D shapes of the beams, but you were not getting signal on one side of the line and no signal on the other. It's very much a haze, I guess you could say. You're picking up signal really no matter where you're at relative to the antenna. If you're nearby the antenna, the least amount of signal here, but there's still some signal that can be measured with the instrument. So thanks for watching.